Hi everyone, my name is Youssef Saleh and today I'm going to be presenting to you how to solve 4 paper 1 questions from topic 11. And all the questions are from past IB examination papers. Question 1 it's a multiple choice question and you shouldn't stay on it more than 2 minutes. So the question says that a student measures the mass of a solid through an analytical balance. He gets the uncertainty of plus or minus 0.01 grams. First of all, we need to keep in mind that the units for the answer would be in grams, like the uncertainty. And we need to think about what the question is asking us for. So it's asking us for the correctly rounded measurement from these 4 options. That means that the answer is accurate to 0.01 grams, plus or minus 0.01 grams. So when looking at the uncertainty, we need to keep in mind that it's rounded to one significant figure and that's rounded to the same number of decimal places as the measurement. So right here we have 2 decimal places. That means that this right here would be the correct answer because it has 2 decimal places as well. This would be incorrect because it has 1. This would be incorrect because it has 0. And this would be incorrect because it has 3 decimal places. In a paper 2 question, we would write it this way, with the units of course, but since it's a paper 1 question, we choose this option. So for question 2, also another multiple choice question from topic 11, the question is asking us what would be the best method to decreasing a random uncertainty in an acid-based titration experiment. The choices we are given are repeating the titration or measurement, using a different tool or burette to get the titration or measurement, using a different indicator to get the titration, or ensuring that our eye level is the same as the height of the meniscus when reading the measurement of the burette. So since the question is looking for the best method, it would be repeating the titration, because repeating the measurement at the end would reduce the random uncertainty because it would give us the average or it would average out our results or measurements at the end. So that's why it's the best method. So this is the correct answer. Using a different indicator is incorrect because it may result in other errors. So it's not the best method. And so is using a different tool may also result in different errors. So that's not the best method as well. We can automatically take out these 2 results. And then ensuring that our eye level is the same as the height of the meniscus, this one may reduce the parallax error in the experiment, but it might not reduce the random uncertainty. That's why it's also incorrect. So at the end, our correct answer is repeating the titration to reduce the random uncertainty. So question number 3 is also a multiple choice question as well, so we have 4 options. First of all, P in the options stands for precise and A stands for accurate. So the question we are given says that a student weighs a standard 70.00 gram mass 5 times on the same balance. Each time he gets 71.20 grams. And then the question wants us to say or to choose whether these values are precise, accurate, both, or not precise and not accurate, so none. So the student measured this value 5 times and he got the same measurement all 5 times. This means that the answer is precise. The measurements are precise. Why is that? Precise means that the measurements are close to each other. Accurate means that the measurements are close to the correct value or the accepted value. So 70 grams is the accepted value, and the 5 times he measured the 70 grams, he got 71.20 grams. So there's almost no difference between each trial he did. So that's why the results are precise. They are not accurate because they aren't close to the accepted value. They can't be both because they're only precise, and they can't be none because the results are really close to each other because they are basically the same result. So they aren't none. The answer would be precise here for this question. So for question number 4, which is also a multiple choice question from paper 1, we're asked to find the correct number of sig figs or significant figures in this value right here, in this number. The options we're given are 3, 4, 5, or 6 significant figures in the measurement or value. So let's recall the rules really quickly for significant figures. Leading zeros never count as significant figures. Non-zeros always count as significant figures. Captive zeros always count as significant figures, and trailing zeros only count as significant figures if there is a decimal point in the measurement or value. So let's start decomposing the number we have. We have two leading zeros. This means that they don't count as significant figures. Then we have 3 non-zeros. Non-zeros always count as significant figures, so they are 3 significant figures. Then we have 1 trailing zero, and there is a decimal point in the value, so it does count as a significant figure. So in total, we have 4 sig figs in the equation, in the measurement we have. So this would be the correct option. 3 significant figures is incorrect because that would just mean that the non-zeros are significant figures without the trailing zero. And this is incorrect. 5 and 6 significant figures are incorrect because leading zeros never count as significant figures. At the end, thank you for watching, and I hope these videos really helped you. So thank you for watching and have a nice day.